Okay guys, let's do more examples applying our double angles, our compound angles, and all the rules that we learned in grade 10 and grade 11. Alright, so what we have here is example 1. Simplify the following expressions. So in these problems, we're going to use the rules that we've already learned. Okay, we're simplifying. Alright, let's go to A. So in A, we're given sine into 360 minus alpha times cos into 180 minus beta plus cos into 360 minus alpha times sine into 180 plus beta. Okay, so for the first step, what do we do? Okay, how do we simplify this? We just apply our reduction formula. Okay, so sine, this is in quadrant 4. Sine in quadrant 4, it's negative, so it's going to be negative sine alpha times cos into 180 minus beta is in quadrant 2. So in quadrant 2, it's only sign that's positive. So since it's cos, we're going to have negative cos beta. Okay, this one, quadrant 4, and its cos, it's going to be positive. So we have plus cos alpha. Okay, this one, sine into 180 plus beta is in quadrant 3. And in quadrant 3, only tan is positive. So since it's sine, we're going to have negative sine beta. Alright, so we're simplifying this thing. Okay, the next step is to, we can see that we have a negative and a negative, which will give us a positive. So we'll have sine alpha times cos beta, and then on this side a positive and a negative will give us a negative cos alpha times sine beta. Okay, I hope everything is still clear. Okay, what's the next step now? We can see we have sine cos sine, and this thing is closely related to our sine compound formula. So we can apply our sine compound formula, and I can see this angle is the same as this angle, this angle is the same as this angle. So I'll have sine alpha negative beta. So this is my final answer. I've simplified this thing. Okay, let's go to B. Okay, in B I have cos into negative theta times cos into 360 plus theta plus cos into 90 minus theta times sine into 540 plus theta. And I have to simplify this thing. And I know when I'm looking at this, I know that cos is it's an even function. Okay, by even function, what do I mean? Let me make an example. Quick example. Okay, so by even function, this is what I mean. If I have maybe f of x is equals to x to the 2, and I have g of x x to the 3. Okay, and then I say substitutes negative x into your function, negative x into your function. It's just a rough example. So what am I going to have? I'll have f into negative x close is equals to negative x to the 2. Okay, and then here I'm going to have g negative x close is equals to negative x to the 3. And the final answer here will be negative x, negative and negative, positive x to the 2. So this one, we know that 2 is even. So in other words, this is an even function. Okay, and this one, I'll have negative x negative x. So I know these two will give me positive x to the 2, negative x. And then I'll have negative x to the 3 as my final answer. And this is an odd function. Okay, so even function, if you're substituting something that's negative within the bracket, as you can see, I substitute negative x, I got a positive x. This is an even function. It behaves the same as cos. Cos is an even function. And when we look at this one, this is an odd function. This is an odd function. As you can see, we have 3 to the 3. We have to the 3 as our power. And I substituted negative x. Okay, when I substitute negative x, I got a negative x to the 3. Negative answer. As you can see, when you substitute something negative in the brackets of an odd function, you get you get a negative answer. So that's what I'm saying when I usually say sine is a odd function. Okay, cos is a even function. That's what I'm usually referring to. All right, so as you can see here, cos is an even function. So since cos is an even function, I'll get positive cos theta, okay, times this cos into 360 plus theta is in quadrant 1. Why am I saying it's in quadrant 1? Okay, it's something like this. So 360, we said if it's positive, we go counterclockwise. So 360 is here, plus that angle, which is an acute angle, so it will fall here. 360 plus an acute angle, it will fall here, which means it's positive. All ratios in quadrant 1 are positive. So I'll have cos theta, which is positive. Okay, and then this is a cofunction. Cofunction, and I know 90 minus theta is in quadrant 1, so I will have positive sine theta, okay, times 504 plus theta. So which quadrant is this thing in? Which quadrant is this thing in? It's in quadrant. How do I find that? I said 540 minus 360. So so in other words, what I have here, I said 540 because I want to see which quadrant this thing is in. It's 540 minus 180. Sorry, 540 minus 360. I get 180. So in other words, I can write 540 as 360 plus 180. Okay, how does this help me? 360, I know that 360, since it's positive, I'll move in counterclockwise direction. 360, it's here, that's where it ends, plus 180. 180, continue to here. Okay, so 540, it's between quadrant 2 and quadrant 3. It's between quadrant 2 and quadrant 3. All right, and then I add an acute angle. So if I add an acute angle to this angle, I'll be somewhere here. So this is a quadrant 3. Quadrant 3. So sine in quadrant 3 is negative. So I'll have negative sine theta. Okay, I hope this was clear. I hope this thing was clear. All right, the next step, I can see I have cos times cos plus sine times sine. So what I'll have cos squared theta negative sine squared theta. Okay, this thing is the same as cos 2 theta. So I've simplified it. Okay, I've simplified it. All right, and then let's go to C. C, I have sine into 180 minus x. Okay, so this is in quadrant 2. Sine in quadrant 2 is positive, so I'll have sine x times, okay, times sine into 90 minus x. So this is a cofunction, so it's in quadrant 1. So all ratios in quadrant 1 are positive, so I'll have positive, but it will be cos x. Okay, then plus, okay, this one I can clearly see this one is a bit it's a bit unusual, okay, but it's still, we can still apply the same rule, okay, the same rules. So what I will do with this one is I'll factor out -1. So I'll have cos, big brackets, -1 out. I will be left with 180, that is positive, and negative x. Okay, so I've factored out -1 to this thing. Okay, I've factored out -1. So, okay, this one, since this one is an odd function, it will be negative, it will be negative sine x. Okay, so that's what I'm left with. So I want to take this thing and now I'm going to work with it on the side, because I wanna demonstrate something. So what I have cos into -1, 180 minus x, close big brackets. All right, so if I equate this thing, if I can equate this thing to, let's say, to alpha, okay? In other words, I have alpha is equals to 180 minus x. I'm equating this thing in my brackets, small brackets. I'm equating it to alpha. So in other words, what I have now is cos negative alpha. Okay, so I know that cos is an even function. So since cos is an even function, I can write this thing like this, cos alpha. All right, and then I bring back my 180 minus x, so cos into 180 minus x. Now it's something that I'm used to, something that I know. I know this thing will be, okay, it's in quadrant 2 and it will be negative since only sign is positive in quadrant 2. So I'll have cos x. All right, I hope this thing makes sense. Okay, so with time, when you're dealing with these things, it will become easier and easier and easier, and you won't have to do the step like this. Okay, you just go straight to the answer with time. But I did this because I want you to understand. All right, okay, so all right, the next step now is sine x times cos x. Okay, I said this whole thing is negative cos x times negative sine x. All right, and then the next step I can see, okay, let me just simplify this thing before I apply maybe a compound formula. All right, I have sine x times cos x. This negative here is going to make this positive. Cos x times times sine x. All right. Okay, so all right, so I can see I have sine I have cos, I have cos, I have sine. This thing is very close. This thing is not even very close. It's a sine compound angle. I can see it's a sine compound angle. This angle is the same as this angle. This angle is the same as this angle. So I can apply a sine compound angle formula, which is sine x, I'll take positive x, and then what I'm left with is sine 2x. Okay, or you or in this step I could have just added these two things. I could have just added these two things. Yeah, I would have arrived I would have arrived to the same answer. Okay, all right, I hope everything is clear. That was example 1. So I would like us to move on to the next example. So this one, sine 2x. Yeah, everything is okay. So I would like us to move on to the next example. Okay. So, all right. So this is page 9. All right. Okay, please take this down for me. Example 2. Simplify. Simplify. Okay, so this is cos 720 minus 2x minus 2 alpha close all over sine to the 2 180 plus alpha close plus sine 90 times cos plus 180. Okay, so we are required to simplify this thing. All right, so it's cos into 720 minus 2 alpha all over sine squared into 180 plus alpha plus sine into 90 plus alpha times cos into alpha, there's a bracket here, cos into alpha plus 180. Okay, cos into alpha plus 180. Okay, so we're required to simplify this thing. Okay, so if I'm looking at the numerator, there are two ways of doing this thing. I can do it using a reduction formula, or I can do it using the compound angles formula. Okay, compound angles formula. Okay, so let's do this using the compound angle formula. I'll also show you how to do it using the reduction formula. The reduction formula, it's very short, it's very quick. So I would advise you to use the reduction formula. But we'll start by applying. We will start by using the method that uses the compound angle formula. Okay, so what I'll have is cos sine. It's cos 720 cos 2 alpha. It's negative, which means I'll have positive sine 720 sine 2 alpha. All right, all over. Okay, so here it's in quadrant sine squared into 180 plus alpha. This is in quadrant is in quadrant 3. Okay, so it will be negative, but since we have to the 2 there, which is an even function, this thing will end up being positive. Okay, so let me do it from the side. Okay. All right, so okay, let's look at sine squared into 180 plus alpha. So I can write this like this: a big brackets sine into 180 plus alpha close to the 2. Okay, so and then I solve what's in the brackets. Sine into 180 plus alpha is in quadrant 3, and I know it's only tan that's positive in quadrant 3, so I'll have negative sine negative sine alpha to the 2. I know this thing can be written like this: sine alpha negative sine alpha. The negative and negative will give me positive, so I will have sine to the 2 alpha. All right, so yeah, I hope this is clear. So in other words, whenever we encounter whenever we encounter ratios that are raised to the 2, to the 4, to the 6, raised to an even number, a ratio raised to an even number, it's always going to be positive. Okay, it's always going to be positive. All right. Okay. All right. I hope that was. I hope that's clear. Okay. So all right. So let's move on. Okay. So this we said it's going to be positive sine squared alpha. Okay, and then here we know this one sine into 90 plus alpha is in quadrant 2, so sine in quadrant 2 is positive, so I'm going to have positive, but it's going to be cos alpha. All right, times cos this is in quadrant quadrant 3, it's 180 plus alpha. Okay, but in here it's written in reverse, it's alpha plus 180. So this cos into alpha plus 180 is in quadrant 3, and it's only tan that's positive in quadrant 3, so I'll have negative cos alpha. All right, so the next step here. All right, so 720. Where is 720 in our Cartesian plane? 720. Okay, this thing is killing me. 720 in our Cartesian plane. Okay, so let's look at our Cartesian plane. So I said 720 minus 360. Okay, 720 minus 360, I get 360. In other words, 720 is 360 plus 360. All right, so we go from here all the way to here. Okay, that's the first 360, and again another cycle. So it's here between quadrant 1 in quadrant 4. Okay, so it's somewhere here. All right. Okay, so it shares the same terminal side and initial side as 0. Okay, it shares the same initial side and the terminal side as 0. So I can say, let me do it here. I can say cos 720 minus 360. Okay, I reduce this thing to an acute angle, so it will cos 360, and then cos 360 minus 360, it will be cos 0. So whenever we have angles like this one, angles that are greater than 360, we always minus 360 to those angles until they are less than 360. Okay, I repeat, whenever we have angles that are greater than 360, we always minus or subtract 360 to those angles until they are less than 360. So I'm using that rule. So here I subtracted 360. I got 360. It's still 360, and I subtracted 360 again, so it was and it became 0. So whenever we have angles that are 360 or more, we always subtract 360 such that they become an acute angle, or they are within our quadrants, quadrant 4, quadrant 3, quadrant 2, or quadrant 1. All right, so that's what I did here. So I know this is it's equivalent to cos 0, I get it's equivalent to 1. Okay, so it's equivalent to 1. If someone asks you why is it 1, did you use a calculator? No, you did not use a calculator. You know this graph by heart, which is 90, 180, 270, 360. So here we have 1, negative 1, 1. And then you know that the graph goes from here, here, and it turns at 180, and then that's where it ends. So if you have cos 0, that's like your x. So if you have cos 0 is here, it corresponds to that. So it's 0 is to 1. So that's why it's 1. Okay, if someone asks you, you must know these graphs by heart, the basic graphs of sine, cos, and tan. They are very useful. Okay, so in other words, we have 1. All right. So here, it's 1. Okay, I won't show the steps here because I've already done them aside. Okay, and then we have cos 2 alpha plus 720. You can just plug this into a calculator because we've already seen it. Sine 720, you get 0 times sine 2 alpha all over. So here on the denominator, what can we do? We can just simplify this into sine squared alpha negative cos squared alpha. All right, that's what we're having now. Okay, on the numerator, if I simplify this thing, I'll have cos 2 alpha, and then this thing will be 0. Okay, anything multiplied by 0 is equals to 0. Okay, all over sine to the 2 alpha minus cos to the 2 alpha. All right, so this thing, it's almost the same as the identity, the double angle, of course. Okay, the identity of a double angle, of course. But the only thing that's messing this thing up is that negative. What if I factor out a negative? What will happen? So I'll have cos 2 alpha. And if I factor out a negative, I will have negative here. This will be positive, cos squared alpha. Subtract. This one will be negative, sine to the 2 alpha. And then I can change this thing to a double angle, of course. Okay, this one will be cos 2 alpha. And this one and this one left with negative 1. Alright, so my answer is negative 1. Okay, my answer is negative 1. From here, I could have used a reduction formula. How do I use a reduction formula here? Okay, so I have cos 720 minus 2 alpha. Okay, I could have used a reduction formula. So firstly, I must get where 720 is, and I know that 720 it's in quadrant. It's between quadrant 1 and quadrant 4. Okay, quadrant 1 and quadrant 4. This one, and this one I should treat this one as an acute angle. Okay, because you see 2 here, the coefficient of alpha is 2. Don't assume it's not don't assume that it's not an acute angle. So this one, you treat this one as an acute angle. So if I'm having this angle, which is here, this one, it's somewhere here, and then I add an acute angle, my angle will fall here on quadrant 1. Okay, so in quadrant 1 all ratios are positive, which means if I reduce this, it will be cos 2 alpha, which is positive. Cos 2 alpha, cos 2 alpha, cos 2 alpha, cos 2 alpha. All right, that's how you do it. So in other words, you treat this angle as an acute angle, this angle as an acute angle. All right, that's another way of doing it. Okay, I hope this one was clear. Let's move on to the next example, which is example 3. Okay. Okay, example 3. Okay, example 3. Okay, so example 3. Simplify the B. sine to the 2 90 plus alpha c and have c. All right, so example 3. Okay, example 3. So we need to simplify these two expressions. Okay, let's do this one. So so I know that tan is it's an odd function, so it will be negative. So I have negative tan theta times so since it's to the 2, I know it will be positive. It's cos to the 2. I know this will be positive because it's an even function. So I know this will be cos to the 2 theta. Okay, and then this is in quadrant 4. Okay, this is in quadrant 4 and it's sine. I know that in quadrant 4 it's only cos that's positive, and I have sine here, so it's going to be negative sine theta. Okay, I know that tan, I can write tan like this, theta times cos theta times cos theta all over negative sine theta. This one and this one, they cancel out each other. I'm left with negative sine theta times cos theta. So these are like this, all over 1. Okay, all over 1. So this one cancels out with this one. Sine times theta, sine theta, negative sine theta times cos theta is equals to this. So negative sine theta, this and this, they are gone. I'm left with cos theta. So these are very nice, very enjoyable. Okay, very nice. Okay, all right, so B, I believe you can do B. I believe in you. You can do B. The answer in B is 2. You can do B. I'll leave B for you to do. All right. Okay, so let's do example 4. Okay, simplify the following expression. Okay, so A, we have 2 cos into negative x, negative 180 close times cos 90 plus x all over 1 minus 2 sine to the 2 negative x. And then B, I have 1 minus sine to the 2 into 180 plus 2x close all over 1 plus 2 cos into 180 plus x close sine 290 minus x close. All right, let's look at the solutions. Okay, let's look at A. So A, I have 2 cos into negative x, negative 108. Okay, so I can factor out negative 1 here, okay, because it looks like something that I'm not used to. But if I factor out negative 1, I'm gonna have something that I'm used to. Okay, let's do this aside. So I have cos to cos negative x, negative 180. Okay, I said if we factor out negative 1, it's going to be something that we are used to. Okay, all right, so it's 2 cos negative 1, so this will be positive 180, and this one will be positive. Okay, so if I can equate this to alpha is equals to 180 plus x, I'll have something like this: 2 cos into negative alpha. Okay, of which I know that 2, since cos is an even function, it will 2 cos alpha, it will be positive. Of which, if I substitute my 180 plus x back, I'll have 2 cos into 180 plus x. I know this thing, okay? This thing is in quadrant 3, okay, which means it will be negative cos x. All right. So I also in this problem I also did it a long way. I took a long way, but with time from here I can tell what's the answer. Okay. So when you have practiced enough, from here you'll be able to tell what's the answer. All right. So here we'll have negative 2 cos x times, so this one is a cofunction and it's in quadrant 2. I know in quadrant 2 cos is negative, but since it's a cofunction it will change to sine x. All right, so this one I know it's 1 minus 2. Since this is to the 2, it's an even function, this thing will be positive. Okay, this thing will be positive. I will have sine to the 2x. Okay, there's no need for me to even to do this thing aside from the side, okay, because I've already mentioned it. Okay, so and then the next step here, we'll have 2 cos x times sine x. Okay, the negative and negative is positive. So this thing is a double angle, it's a cos double angle. This thing is a cos double angle, so I can change this to cos 2x. All right, this one I can say this thing is it's a sine double angle. It's just that it's not arranged the way we are usually used to. Okay, this thing, but it's a double angle for sine. So it's 2 sine x times cos x all over cos 2x. Okay, I've just rearranged this thing, the numerator. So I can say now I have sine 2x all over cos 2x, of which is equivalent to tan 2x. All right, so that's my answer. All right, let's do B. Let's go to B. Okay, so B, I know whatever I'm going to get here is going to be positive because of this 2. Okay, so I can just go straight to my first step. I'll go to have sine to the 2 of 2x. Okay, 2x all over. All right, so here I have 1 plus 2 cos into this. So this is in quadrant 3, of which it means it's going to be negative 2 cos x times, this is in quadrant 1, so everything in quadrant 1 is positive, and it's going to change to cos x because it's a cofunction. All right, next step. The next step, what about the denominator? Okay, the denominator I can, okay, next step, let me just simplify whatever that I have. So this will be 1 minus, this one is going to be 2 cos squared x. Excuse me. 2 cos squared x. Excuse me. So in this one, if I can factor out -1, okay, it will be something that I know. It will change to something that I know. So I have 1 minus sine to the 2x close. So I factor out that -1. This one will be positive cos 2x, and this one will be -1 close.